Okay, so on page 10, we're going to talk about angles in the circle. So yesterday we talked about the tangent radius property, how it always makes a 90-degree angle. So whenever you have a chord and you have a radius and you have a line that bisects it, it always makes a 90-degree angle through the center. And also any chord from the any chord with the center of the circle always makes an isosceles triangle because the two sides are both your radius. Okay, so that's what we did yesterday. Today we talk about angles in the circle. How many of you already know inscribe and central angle what they are? Okay, so good. That's a good amount because this is new to in the grade 9 curriculum. So inscribe angle, as I mentioned yesterday, is from any arc, and you draw it to any part of the circumference. It will those angles are called your inscribe angles, and they're all the same. Okay. And then if you point it to your center, that's called a central angle, and it's twice as big as your inscribe. Okay, so that's the connection between them. Okay. Somebody's food smells good. Okay, so let's do a quick little recap. Okay, so page 11. So having that said, if my inscribed angle here is 30, what is x? Tenzi. 60. Yes, you had to swallow that food first, right? All right, 60. What about number 2? If this is 40, what is x? Noel? Okay, this is my inscribed angle. This is actually also my inscribed angle because they're bounded by this arc right here. They share the same arc, and so that is also 40. Okay, number 3, what we worked on yesterday. What is that angle right there? Ryan, 90 degrees. Okay, and why it's 90 degrees? Because uh, your chord is your diameter. So whenever you have a diameter, your inscribed, whenever your chord is the diameter, your inscribed angle is 90 degrees because the central angle right here is 180. Okay. Number 4, the tangent from a point outside the circle are equal length. So if this is 6, that means this is also 6 centimeters. Okay, right here we're talking about the length. So it's centimeters, not degrees. Okay. We don't usually use this. You might use this more in, I think, grade 11. Okay, so, but just FYI. Number 5, what we talked about yesterday, you have a perpendicular bisector, and so DB is also 5 centimeters. Okay, and the word that we talked about yesterday, OD, is called the perpendicular bisector. Okay, and then also yesterday, radius tangent rule, so that angle right there is 90 degrees. Okay. Number 7, opposite angles in a quadrilateral add up to 180 degrees. This is only true if it's a quadrilateral inside a circle. Okay, so not all quadrilateral are apply. So here, if this is 80, that means x is 100. Okay, because they add up to 180. So same thing for these two sides, they will also add up to 180. Okay, and then last one, the angle between the chord and the tangent through one of the endpoints of the chord is equal to the angle of the alternate segment. So this right here is also 60 degrees, but this one we don't really use much. Like even in grade, maybe grade 12, but even grade 11, we don't usually apply this property. Okay. So let's do 3 examples together. So what is angle X? Okay, take a look at the diagram. Who has an answer for me? What's x? Ryan. Why? Right, and what is this angle called? A right, inscribed angle. Okay, A and B is your arc right here. And so when you draw it to the circumference, those angles are the same. Okay, so what is y then? Okay, yeah, Casey? 110, and why is that? Okay, what is that angle called? Central angle, right? On the test, I've seen it so many times, and I'm not being picky. Right? This is not called the center angle. There's no such thing as center angle. It's called central. It's just like if I call your name wrong, it's wrong. Okay. Example 2. So the rectangle in ABCD has its vertices on a circle with radius 8.5. The width of the rectangle is 10 centimeters. What is its length? Okay. So who has an idea for me? I want to figure out how long BD is. I want to figure out how long this line is right here. Okay, so what can we do? I need some ideas. Do you see a right angle triangle in there? Let's see. Grace. You can draw a line between the center and to here? Between that, like here? But that won't help us do. Okay, that's okay. Joanna, how about you? Any idea? Good. Right. All right. So if this is your diameter, that means this angle right here is 90 degrees. And it actually tells you that it's a rectangle. So then that means I know this is 90 degrees. This is my right angle triangle. So something like this. So this A and C is going to be 17 centimeters. And then this side, I know it's 10. So I'm looking for the odd side. So a square equals square root of 17 square, take away 10 square. So A equals, which is the length of BC. So 17 times 17, take away 10 times 10, square root that, square root 189. You get 13.7. Okay, so therefore the length BC is 13.7. What's my unit here? Centimeters, because we're talking about a length. So I've seen it so many times. People don't pay attention to these little details, and then at the end, after using Pythagorean theorem, they put 13.7 degrees. Okay? So remember, Pythagorean theorem just deals with the length; it never deals with angles. Okay. When you get into the cosine law and sine law in grade 10. Okay, example 3, triangle ABC is inscribed in the circle. So AOB, that's 100 degrees. COB is 140. Okay, determine the value of X, Y, and Z. Okay, so first off, what is X? Okay, how many degrees is a circle? Zoe? 360, right? So if I know two parts of the circle, So 360, take away 100, take away 140. That means x is minus 240, 120. Okay. Y, angle Y. Okay, this is a little tricky. Okay, how do we find out what angle Y is? Shrenik, what's your idea?
Since they're both the radii, it's an isosceles triangle.
Mm-hmm.
So we can just subtract 100 from 180.
Good.
80 over 2 is 4
Good. So
degrees.
180 minus 100, because this is 100 right here. So that's 80, and then you have to split that angle with these two angles right here, because I know this triangle adds up to 180. So when you 80 divided by 2, that means that's 40 degrees. But is y 40 degrees? Is the whole angle y 40? Shanik? Is that your final answer? Y equals 40 degrees?
No, because we still have to determine.
Right. The angle it was only part of the angle y. That was 40 degrees. You still have this part of the angle of y. So you do exactly the same thing, because I know that this and this is also another isosceles triangle. So 180, take away 140, and then split it between the two small angle right here. Okay, so 40 divided by 2, you get 20. So when you add it up together, that means y equals 60 degrees. Okay, so this one was a little tricky, but as I said, any triangle you make with the chord and the center is always an isosceles triangle. Oh, question.
Can you also add 120 divided by 2 because it's the central angle of A.
Good. Yes, that would have been an easier way to do this question. All right, so AC right here. Okay, if you look at the arc AC, this is your central angle, which means this is your inscribed angle. So that angle right there is half of it, which is 60. Okay, good job. And last one, Z. So now Z, we can do what we did. This is another isosceles triangle. So I know that angle X is 120. So 180, take away 120, divided by 2, because I have to split it between these two angles. So 60 divided by 2, angle Z is 30 degrees. Okay. Okay, so I want you guys to take about 5 minutes, 5 to 10 minutes. Try page 13 and 14, and then I'm gonna ask for your answers around the class. Okay, so these 12 circles, page 13, 14. Work on it for the next 10 minutes, and then we'll take it up. And if you're done, your homework is the next 2 page, 15 and 16. Right, but right now I want you guys to try these 12 circles. Alrighty, so you had a chance to try these questions. Let's pick them up. I'm gonna go around the class. Aiden, first one. What did you get? How did you get 53? Right. Okay, again, this is your chord, radius, so that means those two sides are equal. So 180, take away the top angle, which is 74, and then whatever's left, you have to split it between these two angles. And so when you divide it by 2, sorry, what did you say? No, 53 degrees. Good. All right, number 2, Tenzi.
Which page are we on?
13, number 2.
Number 2, fine.
What is saying?
Is it 90 degrees?
It is. Why? Why is it 90 degrees? You have to give your justification. What's your justification? On the test, it's gonna ask for justification and you'll have to give an answer. Okay, what is this angle? Okay, let me ask let me rephrase my question. What's your central angle here? What's the central angle? 180. So if this is 180 and this is your central angle, this is your inscribed angle. So that's why it's 90. This is actually your inscribed angle. Okay. And the second justification you can give is because your chord is your diameter. So your inscribed angle is 90 degrees. Okay. Number 3, foam. What is X?
X is 180 degrees minus 98 degrees because opposite angles in a quadrilateral circle out of 180.
Good. Okay, and so X is?
82.
82 degrees. Good. And Y, Connor? What would Y be then?
That's the one.
Okay, Kingsley?
Y
70 degrees because it adds up to 180. Okay. Next, number 4. Felix. What? Let's solve for this first. This angle right here. What is this angle?
90.
90 degrees. So if I know that this is 90 degrees, I can solve for x. 3x minus 9 equal 90. Move that 9 over. You get 3x equals 81. Oh, sorry, not 99. My bad. You add. So 90 plus 9, you get 99. 99 divided by 3. So Felix, what did you get for x?
33.
33. So x equals 33, 33, just 33, not degrees, right? So then what is this angle? What is angle B? So that means this angle is 34 degrees, so y is 34 degrees. Okay, this part is a little tricky right here because notice I only put the degree symbol on the y, but not the degree symbol on the x, because x is just a value. But then y right here, this is the angle. Okay. Number 5. Yeah. Ethan.
X is equal to 120 degrees.
Because?
The angle at the middle is twice that of the angle at the circumference.
Right, what is that angle called? Starts with a C.
Central angle.
Central angle. Okay, again on the test, if I ask you for your justification and you say center angle, you're not going to get the mark. Right, that's your arc. So this is your inscribed, this is your central. Okay, Edward, number 6. 32, why? Right, that's your inscribed angle. It's bounded by this arc down here. This is your arc, so both of those are your inscribed angles. Right, number 7, Russell.
Number 7 is 32 degrees.
Yep, same reason. That's your inscribed angle. This is your arc. Okay. Number 8. This one is a little tricky. Maxwell, what is x? 46, not 23. It looks like a 23-degree angle, but it's actually 46. Why is it 46? Central. This is actually your central angle. Okay, it's bounded by this arc right here. Okay, so you see this arc, it goes to the circumference, which is 23, And then here, when it goes to your center, that's your central angle, so it's double. All right, this one was a tricky one. Number 9, Ryan. 75. How do you know? Right, opposite. Okay, we learned about this in on Tuesday. Okay. Number 10. This one is another tricky one. Aaron, did you get this one? Okay. Shrenik. Yeah.
Which one?
Yeah. 34? Where'd you get 34 from?
You can just.
You mean 37?
Oh wait, 37.
Okay.
37.
Yeah. Okay. Why? Why though?
Why?
Yeah.
You can see that the triangles are congruent by side, right? So you can just do it.
But this length is not necessarily equal to this length. And better justification. Another justification. Simon, I know you just came in, but
Yeah, they subtend the same length of arc because of
good.
line.
Right. So this arc, because you know the length of this chord is the same length as this chord, so that means you know that this subtend arc is the same as this. So that means this arc making this inscribed angle is the same as this arc that makes this angle. Okay, so this is actually your inscribed angle. Right? They are bounded by the same arc. Okay. Number 11. Lexi, you want to try this one? Pass? Okay. Casey, what is X? 7 meters. Okay, and that's because this is your perpendicular bisector. All right. Perpendicular bisector, which means that both sides are equal. We talked about one of this property yesterday. Okay. And then last one, Joanna. X. 34 degrees. How did you get that?
I did 180 minus 94 minus.
Right. So X equals 180 minus, whoops, a little hard to see here. Okay. This is my arc here. So if you take a look at this arc, this is my inscribed angle 52. That means this angle right here is also 52. So 52, 94, that's how you can figure out what X is. So 180 minus 52, the whiteout is not dry, minus 94. And then you'll get 34. Okay, how many of you got all 12 correct? All right, how many of you got majority of them correct? All right, good. So there you go. That's you've learned everything you need to know for the upcoming test on Tuesday. Tomorrow. So tonight your homework is page 15 and 16, which is more practice on these circle angles. And then tomorrow we do the review. Right? And then once we're done the review, tests on Tuesday. Okay, as I said, this is a very short chapter. There's just so much we need to know about angles. Okay, any questions? What's for homework tonight? 15 and 16. Thank you, Sunny. All right, 15, 16.